Okay, I'm going to try to make this somewhat quick, but we're talking today about assessing bias in selection. So first we're going to talk about the distinction between fairness and bias. We're going to try to talk a little bit about the legal environment that selection happens in, although you're largely familiar with this from earlier when we talked about legal definitions of bias. Try to talk about the kinds of differences that we see, particularly focusing on mean difference and differential validity versus differential prediction or regression. And I'll mention differential item and test functioning, but that is extremely technical and almost impossible to assess in anything other than a mass testing program. So it's generally beyond the scope of most human resource functions. My camera came back, and we can get more elaborate with this. Like I haven't shown everything that we could have. We could have mean differences with differential validity. We could have mean differences with differential validity and a difference in mean on performance, and therefore we would have mean differences, slope differences, and intercept differences. And that's the thing, if we want to be technical in terms of the nature of the term, like the technical terms that I used earlier. A difference in predictor is going to be what we call a mean difference here. A difference in validity is going to be a slope difference in the regression, and a difference in the average performance of the two groups that we're interested in comparing is going to result in an intercept difference, essentially because it's going to pull one of the regression lines up versus the other one. So here's just a quick summary of differential item and test functioning. This is assessed using item response theory, which I didn't really talk about. There are slides on it in the science and measurement, science, statistics, and measurement lecture, but we didn't talk about it much. But this is basically just a way, this is just a highly technical way of checking whether or not an item or a test works differently for minority or majority group members. And this is important because a lot of, sometimes we'll find that there is some kind of bias in the test, and we might look at the test and sometimes we can figure out why there's a difference. Like a classical example of this would be that there was on, I think, a version of the SAT a question about a regatta, and so like, what is a regatta? A regatta is a kind of boat race, like sailboat race. And so people who were relatively wealthy and from typically at the time, the northeastern United States, answered that question correctly much more frequently than people from internally in the country, from lower socioeconomic backgrounds, and certainly against ethnic and racial minorities, right? Other kinds of cases where this happens is in an similar example, there was a question about that was just a basic math question, but it was couched in terms of a quote-unquote word problem about baseball. Now the question didn't technically assume any knowledge of baseball, but it did use those trappings. So if you come from students coming from one of the many countries in the world where baseball is at least not commonly played or played at all, tended to have more difficulty understanding the purely mathematical information that was being presented within that question, and therefore had more difficulty answering the question than students from, say, the United States, Cuba, Japan, and other countries where baseball is relatively commonly played. So sometimes we can look at it and just be like, oh, this item is biased because it assumes cultural or social information that is differentially accessible to individuals from different socioeconomic backgrounds or cultural backgrounds or something along those lines, chances. But sometimes it's just you don't know, and so differential item and test functioning is just a purely technical way of assessing this, and it just does it by essentially all it does is look to see if a person from the minority group has a lower chance of getting the item correct than a majority person of the same ability level. And the reason that we need item response theory, or IRT as it's sometimes known, to do this is because it allows us to simultaneously estimate the difficulty of the item and the person's ability, which other statistical techniques don't let us do, but it also needs really large sample sizes to do it, and that's why this is usually sort of above the pay grade of your typical HR professional, because you will not have the sample sizes necessary to do this unless you're wind up working for something like licensure boards. So things that have tests to do this. So things like the bar exam, nursing licensure exams, those sorts of things. will have the sample sizes to do this, and mass testing programs. So like maybe no one employer is able to do it, but something like the well, I actually forget which company owns. I think it's just Wonderlic Personnel Associates owns the Wonderlic test, the Wonderlic Cognitive Ability Test. The company that distributes and scores that test can assess these things, but each individual employer who does it probably cannot. So you're probably not going to be doing this. I just thought it was worthwhile for you to know it. And so if you have a test that has a bunch, the interesting thing is like in a purely technical sense, items can be biased in either direction. They can be biased against the majority group or the minority group, so that like they have a lower chance of getting the item right, but they can also be biased for them. This rarely happens because the way tests are constructed, they tend to be constructed assessed for functionality and normed on majority group members because they're the majority. So it rarely happens that it's biased in favor. But you can conceivably have a test with a built out of entirely like all items show significant bias, but they show them in a random pattern, and therefore the test is itself unbiased, even though it's made up of a bunch of, in fact, possibly entirely biased items, as long as some are biased up and some are biased down, and you have about the same number that are biased up and biased down. The test may not be biased. And so that's the basic idea here, is if the test has a bunch of biased items and they're all biased in the same direction, then it will display differential test functioning. So diff is differential item functioning, DTF is, although that I understand that means something different in the modern era of internet slang. It means differential test functioning within this context. And this is just a demonstration of what this might look like. These are both of these images show differential test functioning. So you can see here that person of the same ability level, which is this theta here, males have a much lower probability of answering this correctly than females of the same ability. And the same thing goes here. Males are less likely to answer this correctly for any given level of ability than females. It's just an issue here, like the rest of the slope, the rest of the curve looks the same, so it's just that there's a difference vertically in this, whereas here this is called the discrimination. So the test is more discriminating for men, but much more difficult, whereas for women it is slightly less discriminating, but less difficult as well. And again, those are just technical terms. When I say difficult and discriminating, it's just about how vertical this slope is, and how far to the right the point of maximum curvature is on this. So those are purely technical terms, nothing specific to worry about here. And again, I've just drawn the lines in permanently there. So I guess I decided to go traditional when I made this, giving women pink and men blue, or at least semi-traditional. So those are just purely technical concerns here. Anyways, I think this has gone on long enough, and I'll be answering questions because this is probably some of the most technically difficult material in the course. So I'm going to be happy to answer people's questions about it during live sessions. All right, cheers.